try to get a sense of sine, cosine, and other trigonometric ratios. Let us mark certain values of theta that separate different quadrants. So theta is equal to 0, pi by 2, pi, 3 pi by 2, and 2 pi. And let us now demarcate these columns by these vertical lines. So we have these columns for particular values of theta, and we can see that between each successive pair of those theta values, we have a full quadrant. So when theta goes from 0 to pi by 2, we have quadrant 1. When theta goes from pi by 2 to pi, we have quadrant 2. Theta going from pi to 3 pi by 2 is quadrant 3. And theta going from 3 pi by 2 to 2 pi is basically quadrant 4. Now let us first see how cos theta and sin theta would behave as theta goes from 0 to 2 pi. Now what is cos theta when theta is 0? We have earlier calculated this value to be 1. And we can see it from this unit circle as well, that when theta is equal to 0, this segment OP coincides with OA, and its projection on the x-axis OA prime becomes equal to OA, which is nothing but 1. That is the radius of the unit circle. And as theta tends to 0, the projection of OP on the y-axis, that is OB prime, becomes 0. And so we write sine 0 as equal to 0. When theta becomes pi by 2, we can see that segment OP coincides with OB here. And so its projection on y-axis is nothing but OB, which is 1, which is sine theta. And its projection on x-axis is 0, which is cos theta. And when theta is pi, segment OP coincides with segment OC, and therefore cos theta is equal to its projection on the x-axis, which is nothing but OC itself, which is minus 1 in this case because it is on the negative side of the x-axis, and the projection on the y-axis is 0. Therefore we write cos pi as minus 1 and sin pi as 0. And when theta is 3 pi by 2, OP coincides with OD here, and we can see that the projection on y-axis is minus 1, which is sine 3 pi by 2, and the projection on the x-axis is 0, which is cos 3 pi by 2. And when theta becomes 2 pi, we can see that OP will now coincide with OA, and this is the case when theta was 0, and therefore we can write cos 2 pi as 1 and sin 2 pi as 0. And this supports our earlier understanding that as theta increments by 2 pi, its value is equivalent to the original value, and therefore the value of cosine and sine for 0 radians here is equal to their values for 2 pi radians. Let us now see how cosine and sine behave as theta moves from between these specific values. That is, it passes through these quadrants, quadrant 1, quadrant 2, 3 and 4. As theta